A very good morning to all my dear students. Welcome back to online IIT class. Today we are going to discuss about our synopsis 8 problems based on specific heat. This is our first problem. 200 grams of water at 10 degrees centigrade is heated up to temperature 90 degrees centigrade. Calculate the amount of heat given to water. Here specific heat of water is equals to 1 calorie per grams degrees centigrade. Here our formula Q is equals to Q means quantity of heat is equals to mc delta T. It is not theta, it is T. So here Q is the quantity of heat, M means mass of the body. Here specific heat is the letter C, and the constant specific heat is a constant that is equals to already given in our problem. Specific heat of water is equals to 1 calories per gram degree centigrade, and delta capital T means changes in temperature. So here we have to find quantity of heat required. So Q is equals to formula mc delta T. Mass of the body, specific heat, changes in temperature. Here mass of the body is equals to 200 grams and specific heat is equals to 1 calories per gram degree centigrade, and changes in temperature 10 degrees to 90 degrees centigrade. Just substitute these values in our formula. Q is equals to M into C into changes in temperature delta capital T. Here changes in temperature 90 degrees minus 10 is equals to 80 degrees centigrade. So here M into C into delta T. So heat required is equals to 200 into specific heat, that is equals to 1 into 80 changes in temperature. So that is equals to 2 8s are 16 into 1000, 16,000 calories. Here K means 1000. It is a constant, K means. So 16K calories. Heat required is equals to 16K calories. Next problem, second one. Calculate the amount of heat required to raise the temperature of 500 grams of copper from 30 degrees centigrade to 120 degrees centigrade. Here specific heat of copper is equals to 0.095 calories per grams degree centigrade. Actually here specific heat is a constant term. It is varies from body to body. Specific heat is the amount of heat required to raise the temperature of unit mass of substance through 1 degree centigrade or 1 Kelvin. In our first question, our material is water. In this question, our material is a copper. So quantity of heat always depends on three factors. First one, mass of the body, means Q is directly proportional to M. Here Q means quantity of heat. And second one, changes in temperature of body, means delta T. And third one, nature of the material of the body. Here nature of the body means every material has its own specific heat constant. So let's get into the problem. So quality of heat is equals to formula M into C into changes in temperature delta capital T. M into C into delta capital T. M is the mass of the body. C means specific heat of the body. Delta capital T means changes in temperature, T2 minus T1. So here we have to find quantity of heat required. So M is equals to mass of the body is 500 grams and C is equals to specific heat of the body is 0.095 calories per grams degree centigrade, and changes in temperature delta capital T is equals to 120 degrees minus 30 degrees, that is equals to 90 degrees. Here all units are in CGS system. Grams is the CGS system, calories per grams degree centigrade is the CGS system. So we have to find quantity of heat Q. Just substitute these values in our formula. Q is equals to MC delta capital T. So that is equals to 500 into 0.095 into 90. That is equals to 500 into 0.095 into 90 is equals to 4275 calories. It is the quantity of heat of the copper to given parameters. Next problem, third one. Calculate heat capacity of 10 kg of water. Given specific heat capacity of water C is equals to 4.2 joules per grams degrees centigrade. Here heat capacity is equals to Q is equals to M into C. Mass of the body and specific heat of the material. Here specific heat of water is 1 calories per grams degrees centigrade. Here mass of the body is equals to 10 kg, means it is in SI system, and specific capacity of water is equals to 4.2 joules per grams degree centigrade. It is in CGS system. Here actually specific heat of water is 1 calories per grams degree centigrade. So here 1 calorie is equals to 4.2 or 4.18 joules. So C is equals to 1 calories per grams degree centigrade or 4.2 joules per grams degree centigrade. So in this experiment, water doesn't affected by heat loss or heat gain. So changes in temperature delta T, assume it 1. So first we have to change mass of the body 10 kgs to grams. So this is in SI system, change it into CGS system. Here 1 kg is equals to 1000 grams. So mass of the body is equals to 10 into 1000 grams, 10,000 grams. So our formula Q is equals to M into C into delta capital T. M is the mass of the body, C is the specific heat of material. This is material is water, and delta T is the changes in temperature. Here there is no temperature changes takes place. So assume it as 1 degree centigrade. So Q is equals to M into C into delta T. So 10,000 into 4.2. So that is equals to, finally result is 42,000 joules. Here 1 calorie is equals to 4.2 joules or 4.18 joules. So note this point, specific heat of water is 1 calories per gram degree centigrade or 4.2 joules per grams degree centigrade. This is very important conversion. Next problem, fourth one. 100 grams of hot water at 80 degrees centigrade is mixed with 200 grams of cold water at 10 degrees centigrade. What is the temperature of the mixture? So here we divide the problem into two parts. First one is hot water, second one is cold water. Here M1 is the hotter water mass, that is equals to 100 grams, and M2 is the cold water mass, that is equals to 200 grams. And specific heat of hot water is 1 calories per grams degree centigrade, and Cold water specific heat is also 1 calories per grams degree centigrade. So here theta 1 is the temperature of the body at hotter stage and theta 2 is the temperature of the body at colder state. So theta 1 is equals to 80 degrees centigrade and theta 2 is equals to 10 degrees centigrade. This is very important relation. Heat given by the hot body is equals to heat taken by the cold body. Here our formula, heat given by the hot water is equals to heat given by the cold water. So formula M into C into changes in temperature delta T. Is we just balancing this statement by using our formula M1 into C1 into theta 1 minus theta. Here theta is the temperature of the mixture. This is our question mark is equals to M2 into C2 into theta minus theta 2. Here theta 1 is the hotter body temperature and theta 2 is the cold water temperature. Just substitute our values in this formula. So M1 100 into C1 specific heat of water is 1 into theta 1 80 minus theta is equals to M2 cold water mass, that is 200 grams into specific heat of water 1 into theta minus 10. So that is equals to, so in the both sides 100 2 times 200. So finally 80 minus theta is equals to 2 into theta minus 10. So after the transpose, so theta is equals to 33.3 degrees centigrade. This is our final result. In this problem, this relation is very important. Heat given by the hot body is equals to heat taken by the cold body. Next question, fifth one. A piece of metal of mass 250 grams is heated to temperature 300 degrees centigrade. Hot metal is put in 120 grams of water at 20 degrees centigrade. Contained in a calorimeter of mass 200 grams. The final temperature of mixture is, it is not 400, it is 40 degrees centigrade. It is 40 degrees centigrade. Calculate the specific heat capacity of metal. Specific heat of calorimeter is 0.1 calories per grams degrees centigrade. Here the final temperature of mixture is 40 degrees centigrade. The mass is 250 grams at the heated to the temperature 300 degrees centigrade. This is the calorimeter. It is used to process of measuring the heat of chemical reactions or physical reactions. A simple calorimeter consists of just only thermometer attached to a container. So here our formula, heat given by hotter body is equals to heat given by cold body. So that is equals to heat given by solid is equals to our formula Q is equals to MC delta T. Here mass of the metal is 250 grams into C. C means specific heat of metal into changes in temperature delta T. Here the actual temperature of the material is 300 degrees centigrade. Then we put into the water, so we got 40 degrees centigrade. This is the final temperature. So changes in temperature is 300 minus 40. So finally 250 into C into 260. So the result is 65,000 into C calories. Here C means specific heat of material. So next step, heat given by water. So Q2 is equals to MC delta T. So that is equals to mass of the water is 120 grams into water. Specific heat is 1 calories per grams degrees centigrade and changes in temperature 40 minus 20. So that is equals to 120 into 1 into 20, 2400 calories. Heat given by the calorimeter Q3 is equals to M into C into changes in temperature. So that is equals to mass of the calorimeter 200 into Specific heat of calorimeter is equals to 0.1 calories per grams degree centigrade, already given in our problem. So 0.1 into 40 minus 20, that is equals to 200 into 0.1 into 20, result is 400 calories. Here heat given by the hot body is equals to heat taken by the cold body. Similarly, here is also heat given by the solid is equals to heat taken by the water plus heat taken by calorimeter. So that is equals to 65,000. Specific heat constant of material is equals to 2400 plus 400. So C is equals to 2800 by 65,000. Result is 0.04 calories per grams degree centigrade. This is the final result. So here practice sheet 2 as your homework. If you have any doubts in this session, please contact my number. Thank you.
Calorie meter. The exchange of heat depends on three factors. First, mass of the substance, or M. Second, specific heat of the substance, or S. Third, difference in the temperature of the substances, or T. We use calorimeter to find the specific heat of the substance. A calorimeter is a cylindrical copper container kept inside a wooden box. The space between the container and the wooden box is filled with cork, sawdust, glass, or wool. That is basically a substance which is a non-conductor. The wooden container has a lid inserted with a stirrer, and it also has a thermometer. A measured mass of water is taken in the calorimeter and its temperature is noted T1. The substance whose specific heat is to be found is heated up to temperature T2 and then transferred to the calorimeter. The water in the calorimeter is stirred and the final temperature of the mixture T3 is found. With the help of mathematical formula, heat lost is equal to heat gained, we can calculate the specific heat of the substance.
Now we're going to look at the specific heat. Specific heat is defined as the amount of heat required to raise 1 gram of a substance 1 degree Celsius. For example, water has a specific heat of 4.184 joules per gram per Celsius degree. We have a piece of cadmium metal, and we're going to try to find out the specific heat of this metal. We know that the quantity of heat is equal to mass times the specific heat times the change in temperature. So let's start by finding the mass of our sample. The mass of our sample is 58.953 grams. What we're going to do is we're going to heat this sample to 100 degrees, or approximately 100 degrees. We'll get the exact temperature. And we're going to take 100 milliliters of water at room temperature. So let's measure 100 milliliters of water. Remember that 1 milliliter of water is 1 gram. So if we know that we have 100 milliliters, then we know that we have 100 grams. And this is at room temperature. So we know that when we put this hot metal in there, it's going to gain heat. We're going to use our coffee cup calorimeter because it's insulated, and we're going to assume that it gains no heat and the water gains all of the energy that's given off by our metal. So let's find the temperature of our water and the temperature is 22 degrees Celsius. Now we have our water boiling, so we're going to tie a string to our sample so that it doesn't touch the bottom of the beaker. If it touches the bottom of the beaker, then we don't know for sure what the temperature is. But if it stays in the water, then we know that the metal will be the same temperature as the water temperature. So let's put our thermometer in the water, about the same height, and then we'll lower everything in the water together. Okay, and we're going to let this boil long enough that we know that the temperature of the metal is the same temperature as the water. I think we've waited long enough to be confident that our metal and our water are at the same temperature. Our temperature is exactly 100 degrees. So I'm going to take out my thermometer, and I'm going to take my sample, and I'm going to quickly put it in the water. Put the top on, swirl it around, and we're going to swirl the cadmium metal in the water with a thermometer to try to make sure that we get uniform temperature. We'll read our thermometer, and when it stops changing, we'll record that temperature. And it looks like it's steady at 25 degrees C. So that means we have a 3-degree temperature change. So you now have the temperature change in the water, the temperature change in the metal, and the mass of the metal. So your task is to calculate the specific heat of our cadmium metal.